Hello, my name is June Spector, and I'll be talking with you about heat stress and safety issues for farm workers and farmers in the context of climate change. I'll talk first about heat-related illnesses and injuries in agriculture, and then climate considerations, and finally practical solutions and resources for adaptation. There are many different potential effects of heat, and I won't be talking about all of them today. I won't, for example, be talking about the effects of heat on the kidneys, including acute kidney injury, which has been described in California agricultural workers, or the potential role of heat in the development of chronic kidney disease of unknown etiology, which has been classically described in sugarcane harvesters in various parts of the world. Heat also affects the absorption and metabolism of chemicals, and heat interacts with air quality as well, and more work is needed to understand that interaction and potential health effects in agricultural workers. Heat has been studied and reported to affect pregnancy and birth outcomes and mental health outcomes, and also contributes to productivity and economic implications. So while I won't be talking about those potential effects of heat, I will focus on the effects of heat on heat-related illness and heat-related traumatic injuries in agricultural workers. When talking about heat in often otherwise healthy working populations, such as agricultural workers, we have to think about a combination of environmental heat exposure as well as metabolic heat exposure, for example, from heavy physical work that contribute to heat stress. This triggers a normal physiological response in the human body to try and maintain a normal core body temperature, which when overwhelmed can lead to heat-related illnesses, including heat stroke, which can be fatal, heat exhaustion, and other heat-related illnesses. There are a number of different individual, environmental, and workplace factors which can modulate the development of heat-related illnesses. Individual factors may include underlying health conditions. Workplace factors might include water, rest, shade, exertion, and other factors. And environmental factors include not only air temperature, but also humidity, solar radiation, wind, and other factors. It turns out that agriculture is at high risk for heat stress and heat-related illness. In the United States, between 2000 and 2010, we see here that the agriculture, forestry, fishing, and hunting sector had the highest rate ratio for heat fatalities compared to all other industries. We did a survey in 2013 where we surveyed orchard workers in Washington state and determined that about a third of workers reported suffering from heat-related illness or heat strain symptoms during a hot day in the past week. And about half reported some type of concern about health effects caused by hot weather, with about 20% reporting being very concerned about this. When we look at objective measurements, we also see that agricultural workers are experiencing heat strain during the summertime. This was a study of pear and apple harvesters in Washington state, where we assessed whether heat strain was being experienced using American Conference of Governmental Industrial Hygienists methods, or ACGIH methods, based on heart rate and core body temperature, which was estimated using ingestible sensors, which measure temperature in a wireless manner. What we saw was that during August pear harvest, where the mean maximum daily wet bulb globe temperature was 28, that over half of workers experienced some type of heat strain according to the ACGIH definitions. So we've seen now, both in surveillance data as well as survey data and objective measurements in workers, evidence that heat stress and heat strain are occurring. But in order to think about prevention, we have to understand what are the factors that are driving these trends. So in that same survey that I mentioned before, we looked at factors that might be associated with agricultural worker heat-related illness or heat strain symptoms, and found that modifiable workplace factors contribute, including piece rate pay compared to hourly pay, which has actually been shown to increase the risk of injuries in occupational settings as workers are incentivized to work harder, faster, and not incentivized to take breaks, as well as having to walk farther to get to the toilet, with the rationale being that particularly if you're being paid by the piece, staying hydrated, which also may mean needing to urinate more, there may be a disincentive to do that if the toilet is far away and you're being paid by the piece. What about traumatic injuries? We talked about heat-related illnesses. Well, we know that traumatic injuries are quite common in agriculture. These data are from Washington State, and we see that for falls from elevation, Washington State has the fourth highest workers' compensation claim rate in fruit and tree nut farming. It turns out that several studies have looked at heat-related traumatic injuries and identified an association, including in agriculture. There are several proposed mechanisms, and nothing is definitive yet, but one thought is that heat is known to affect cognition and can affect balance. And for tasks such as picking fruit from ladders, this may increase the risk of falls. We conducted an epidemiologic study in Washington State of outdoor agricultural workers using about 12,000 workers' compensation injury claims and found that there was an increased risk of injuries in warm conditions, particularly when the humidex, which is like the heat index, is a combination of temperature and humidity, was 30 to 33 compared to less than 25. And we found this trend during May through September when we looked at all time periods with higher risks during cherry harvest in June and July. And another thing we noted is that there were less injuries occurring in the afternoon times on the hottest days, which suggested to us that growers are doing a great job at thinking about adjusting schedules so that workers aren't working during the hottest time of the days on the hottest days. And so when we exclude injury times after 12:30, we see more of a linear dose-response relationship in this risk. I wanted to shift gears and talk a bit about climate in particular. So this is what we're experiencing now with the weather, but what about in the future with climate change? We know that heat waves are projected to increase in frequency and severity with climate change. And absent mitigation, the Earth's average surface temperature is projected to increase between 2.6 and 4.8 degrees Celsius before the end of this century. We did a study to look at what this might mean for agricultural workers in the future. What we did was we looked at present day, a 2 degrees Celsius warmer world, and a 4 degrees Celsius warmer world to try and understand how many more days and how many more worker days, taking into account agriculture populations, we would see above recommended occupational exposure limits, again using the ACGIH threshold limit value or TLV. And I will say we made many assumptions in this analysis, including using population data, which unfortunately doesn't capture self-employed or undocumented workers. We assume no other adaptations over time or changes in the population. And we also assumed for our base case that workers were working 90% of the time in every hour at a moderate metabolic rate, able to rest in the shade and wearing double layer clothing. And what we see here most markedly is that in the West, which I've highlighted, an increase in to 2 degrees Celsius warmer world and 4 degrees Celsius warmer world, with already some marked note of the number of worker days in the present day, but an increase over time in the Western states. So the question then becomes, what about attempts to actually try and mitigate this risk through work adaptations, such as those recommended by ACGIH? And here what we tried to do was show the number of days above the TLV in the present 2 degrees Celsius and 4 degrees Celsius warmer world if we actually reduce effort of workers, reduce pace, rest in air conditioning instead of in the shade, or single layer clothing instead of double layer clothing, and combinations of these. And you can see that particularly for combinations, we start to get a reduction in the number of days above the TLV. However, reducing effort and pace may not really be practical for growers and farmers. So we have to start thinking then about a multi-pronged approach. And that leads us into thinking about practical solutions and resources for adaptation. As I mentioned, an individual worker or grower can't adapt to this problem alone. We also need to think about climate change mitigation, about land use planning in the built environment, about the availability of trees in agricultural settings for shade, about community cooling opportunities and housing, and policies and plans that really aim to try to equitably address this issue. So multiple levels, community housing, employer, interpersonal, individual, as well as taking into account the traditional industrial hygiene hierarchy of controls on the left with heat elimination, that's climate change mitigation, engineering controls such as areas to cool down, administrative and training opportunities, so thinking about work shift timing without introducing other hazards, as well as clothing and thinking about personal protective equipment. So multiple levels are needed to address this issue. Some states have heat rules, including California and Washington, and Minnesota has an indoor heat rule. We do not have a federal heat rule, but we do have public service announcements emphasizing water, rest, and shade from OSHA, and apps that have been developed with OSHA and the National Institute for Occupational Safety and Health to try and provide some guidance for what to do when it is hot to employers and others. We've put together a toolkit, which is freely available at the link shown here. It tries to get at some of these other levels, community housing, grower, and interpersonal. It includes training for individual workers and trainers, as well as for growers and supervisors, a voluntary heat awareness system, for forecasting for work planning, to help with decision making with agriculture-specific practical tips that ties into growers' precision agriculture frameworks. Other resources are shown here. And I'll conclude by hoping that I've given you some sense of heat-related illnesses and injuries in agriculture in a climate context and some practical solutions to think about. Thanks to everyone involved, and I'm happy to answer questions during the panel session.